Legendary mathematicians. Let us look at question 12, which is an optimization problem from calculus. Right. So in question 12, they say that ABCD is a square with sides 20 millimeters each. PQRS is a rectangle that fits inside the square such that the length of QB is this distance here, is equals to the length of BR, this distance here, is equals to the length of DS, this distance here, is equals to the length of DP, this distance here. This is what we have. So QB is exactly equals to BR, it's equals to DS, and it is equals to DP. So it is equals to K. So which means this is going to give me K here. This is also K here. And this is also K here. And this is also K there. Okay, so if the distance from Q to B is K, and the distance from A to B is 20, so which means the distance from here up until here, the distance from A to Q will be 20 minus K. Similarly, the distance from A to P, the distance from here to here will also be what? 20 minus K. This distance from R to C will also be 20 minus K. And this distance again from S to C is also going to be 20 minus K. So we are asked, okay, in 12.1, we are asked to prove that the area of rectangle PQRS, this is a rectangle, PQRS is given that PQRS is a rectangle there, and it is given that ABCD is a square. So now we need to prove that the area function of rectangle PQRS is given by this expression. How do we do that now? We know that the area of a rectangle is the same as the area of the square, length times breadth. So then I need to calculate the length of this rectangle, and I also need to calculate the breadth of this rectangle. Okay, so now I'm going to 12.1. I'm going to focus on triangle. I'm going to specify which triangle I'm going to focus on. So I'm going to say in triangle, I'm going to specify a triangle that I'm going to work with. So in triangle, let me take ABK. I mean, no, AQK. AQP rather, AQP. Triangle AQP. Triangle AQP. Triangle AQP. This triangle is a right angle triangle. How do we know? We know this simply because we are told that ABCD is a square. So we know that the interior angles of a square, they are all 90 degrees. This is 90 there. This is also 90 here. And this is also 90. So this means triangle AQP is going to be a right angle triangle. Then I can apply Pythagoras theorem to compute the length of PQ. So I'm going to say PQ squared is going to be equals to AP squared. AP squared plus AQ squared. Then I'm going to give the reason there. This is Pythagoras theorem. Pythagoras theorem. That is the reason. Then I'm going to substitute. PQ squared is what I'm looking for. So I'm going to keep it as it is. So AP squared and AQ squared, they are all equal. Those are. So it means basically triangle AQP, it's an isosceles right angle triangle. So I'm going to have 20 minus what here? K all squared plus 20 minus K all squared. So this gives me PQ squared is equals to 2 times 20 minus K all squared. And therefore PQ will give me the square root. So PQ is length. I don't have to write plus or minus. Square root of 2 times 20 minus K all squared. So therefore this means PQ will give me what? Will give me 20 minus K times the square root of 2. units. Okay, in this case here, the unit were given, so I'll just call it millimeters. I'll just call that distance millimeter. I'll put it in millimeters. I'll put that in millimeters. I'll put that in millimeters. Okay, square root of 2 millimeters. This is what I'm going to have. So this now means that this distance PQ, it's going to be 20 minus K times square root of 2 millimeters. Then I'm going to use triangle PDS. I could use triangle QBR if I want to, but I'm going to use triangle PDS to calculate the length of piece S. Again, in triangle, this triangle is also a right angle triangle. So in triangle PDS, I'm going to have PS squared. PS squared will be equals to PD squared. It's a right angle triangle as well. Plus DS squared. Supply the reason there, Pythagoras theorem. And then PS squared is still the subject. This will become K squared plus, this will also become what? K squared. So this means PS squared will give me 2 times K squared. In which case, PS will give me the square root of 2 times K squared, which will give me what? Will give me K square root of 2 millimeters. So that's the distance of this, K times square root of 2 millimeters. Therefore, the area of this rectangle, the area of what? Of PQRS, area of PQRS will be what? The length multiplied by the breadth or the width. So if I take PQ as my length, I'm going to get 20 minus K square root of 2. Then I'm going to multiply that by what? By PS, which is going to be what? K square root of 2. And if I simplify this, this will give me K multiplied by 20 minus K times the square root of 2 all squared. And therefore, this will give me the area of PQRS will be equals to 2K times 20 minus K. And if I like, I can factorize the negative from this bracket here. And if I factorize the negative in this bracket, I'm going to get negative 2K. Then this becomes K minus 20, which is exactly what I had to show there. Then I can simplify, multiply out if I want to. This will give me 40. It's going to give me 40K minus 2K squared. So which is what they asked me to show. This is what they asked me to show. All right. Then we can look at the next question. We can look at the next question. 12.2. I'm at 12.2 now. 12.2. So 12.2, they say I need to find the value of K for which the area of PQRS is a maximum. So the area function of PQRS, I'm going to write it as A of K. It depends on K. A of K will give me what? Negative 2K squared, then plus 40K. So we can see that the area function here, it's actually a quadratic function with a set face. The quadratic function with a set face. So the value of K that will give the maximum here will happen at the axis of symmetry. So it means the equation X is equals to minus B over 2A, which is the axis of symmetry of this quadratic function here, will give us the value. Will give us the value that the value of K that corresponds to a maximum. So let me call it K here because the unknown is K here. So I can see that my A is negative 2. My B, it's equals to 40. And then I'm going to substitute inside it to get that value that will give me a maximum. Of course, it must be a maximum because the leading coefficient is negative. So this will give me negative, I'll say 40. That's the value of B. And then 2 times what? Negative 2. So therefore, that value of K, this will give me 40 over what? Over 4. And therefore, that desired value of K, which will give a maximum, is going to be K is equals to how much? It's going to be 10. K is going to become 10. The value of K that will make this to be a maximum is going to be 10. It's going to be 10, and we can say 10 millimeters. So this is that value. The question says you must find the value of K for which the area is a maximum. They don't want to find what the maximum value is. They are not asking you to find what the maximum area is. They are only asking you to find the value of K that will give you a maximum. And that value of K is going to be equal to 10 millimeters. And that's how we do the question, mathematicians. As easy as that. So I'll stop the video right here. See you again next time, mathematicians. Never stop doing mathematics. We are together.